In this figure, an equilateral triangle with a side of 20 units is inscribed in a square. Find the length of each side of the square. In this video, we are going to solve this problem using two methods. First method. To solve this problem, first let's label this point as P, and this point Q. Next, let the side of the square be A. Let BP be B. And QD B. Since the side of the square is A, then CP will be A minus B. And CQ A minus B. Next let's consider triangle APB. Using Pythagoras theorem in triangle APB will give us A squared plus B squared is equal to 20 squared. 20 squared is 400, so A squared plus B squared is equal to 400. Let's call this equation 1. And same is applicable to triangle ADQ. Next, let's consider triangle CPQ. From Pythagoras theorem, A minus B squared plus A minus B squared is equal to 20 squared. Simplifying this will give us 2 times A minus B squared is equal to 400. Dividing both sides by 2 will leave us with A minus B squared is equal to 200. If we take the square root of both sides, it follows that A minus B is equal to 10 root 2. Next, let's make B the subject of the formula. Doing so will give us B is equal to A minus 10 root 2. Next, let's substitute B with A minus 10 root 2 in equation 1. And this will give us A squared plus A minus 10 root 2 squared is equal to 400. Expanding A minus 10 root 2 squared will give us A squared minus 20A root 2 plus 200. It follows that A squared plus A squared minus 20A root 2 plus 200 is equal to 400. Next, let's collect like terms. Doing so will give us 2A squared minus 20A root 2 minus 200 is equal to 0. Dividing through by 2 will leave us with A squared minus 10A root 2 minus 100 is equal to 0. And this can be written as A squared minus 10 root 2A minus 100 is equal to 0. Observe that this is a quadratic equation. Going further, we are going to use the quadratic equation formula to solve this problem. Given a quadratic equation, ax squared plus bx plus c is equal to 0. The quadratic formula for this equation is x is equal to minus b plus or minus the square root of b squared minus 4 times ac all over 2a. Comparing these two equations, a is equal to 1, b is equal to minus 10 root 2, and c is equal to minus 100. If we plug in these values in the formula above, we will have a is equal to minus 10 root 2 plus or minus the square root of minus 10 root 2 squared minus 4 times 1 times minus 100 all over 2 times 1. Simplifying these will give us a is equal to 10 root 2 plus or minus root 200 plus 400 all over 2, 200 plus 400 is 600. So we have 10 root 2 plus or minus root 600 all over 2. The square root of 600 is 10 root 6. So, we are left with 10 root 2 plus or minus 10 root 6 all over 2, which can be written as a is equal to 10 root 2 over 2 plus or minus 10 root 6 over 2. Dividing through by 2 will give us 5 root 2 plus or minus 5 root 6. Since the side of the square must be positive, it follows that a is equal to 5 root 2 plus 5 root 6. And this is the length of the side of the square. Second method. To solve this problem, let's label the side of the square as we did in step 1. Next let's draw a straight line, from C to A. Let's call this point R. Observe that this line bisects QP, so QR is 10, and RP is 10. Also, AC is equal to AR plus CR. Let's call this equation 1. To find AR, let's consider triangle APR. In triangle APR, AP squared is equal to AR squared plus RP squared. From Pythagoras theorem, AP is 20 and RP is 10. Substituting these values in the equation will give us 20 squared is equal to AR squared plus 10 squared. 20 squared is 400, and 10 squared is equal to 100. If we make AR squared the subject of the formula, it follows that AR squared is equal to 400 minus 100. 400 minus 100 is 300. So, AR squared is equal to 300. Taking the square root of both sides will give us AR is equal to 10 root 3. To find CR, let's consider triangle CPQ. Triangle CPQ is a right triangle, and CR is an altitude drawn from the right angle at C. To find CR, let's consider the inscribed similar right triangles theorem. It states that, in a right triangle, the altitude drawn from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of these two segments. From this theorem, it follows that CR is equal to the square root of 10 times 10. The square root of 10 times 10 is 10. So, CR is equal to 10. Now we know the value of AR and CR. Substituting their values in equation 1 will give us AC is equal to 10 plus 10 root 3. Next, let's consider triangle ABC. In triangle ABC, AC squared is equal to AB squared plus BC squared, from Pythagoras theorem. AB is equal to A. BC is also A. Substituting these values in the equation will give us AC squared is equal to A squared plus A squared. a squared plus a squared is 2a squared. It follows that ac squared is equal to 2a squared. Dividing both sides by 2 will leave us with a squared is equal to ac squared over 2. Taking the square root of both sides will give us a is equal to ac over root 2. Since ac is equal to 10 plus 10 root 3, if we substitute ac with 10 plus 10 root 3 in this equation, we have a is equal to 10 plus 10 root 3 over root 2. To rationalize the denominator, we multiply the numerator and denominator by root 2. Simplifying these expressions will give us 10 root 2 plus 10 root 6 all over 2. Dividing through by 2 will leave us with a is equal to 5 root 2 plus 5 root 6. Thanks for watching. If you liked this video, make sure to subscribe for more.